Every enterprise reaches a precise moment where internal data officially leaves the building and becomes external financial liability. Control systems designed to guard this exit point fail because they are forced to evaluate an incomplete representation of the transaction, often missing crucial context like stale supplier status or hidden approval limits. The standard industry response to this problem is a multi-year integration project, attempting to rewrite governance logic directly inside the legacy ERP core. Castle OS operates on a different rule: do not touch the ERP core. Instead of rebuilding the origin system, we intercept the execution path exactly where the transaction tries to leave. Financial control is achieved by governing the exact boundary where an ERP's output translates into real-world consequence. Building that critical boundary relies on a strict physical separation between preparing the data and actually evaluating it. The architecture divides into two layers. Layer 1, the cleansing layer, interrogates messy source data to ensure it can be trusted. Layer 2, reason gate, then evaluates this clean data against deterministic policies, resulting in a strict pass or block decision. Collapsing these two distinct processes into a single system often obscures structural weaknesses in enterprise finance. The difficulty in deploying these controls lies in mapping the data, not writing the logic. Legacy systems speak distinct structural languages. An SAP database and an Oracle database organize their outputs in ways that are technically incompatible with each other. This canonical transaction schema absorbs diverse outputs into a standardized payload. SAP's LIFNR and Oracle's creditor code both translate into a unified supplier ID slot. This strips legacy technical debt, leaving pure execution intent. Once the data rests in this unified format, deterministic WASM rules only need to be written once for all systems. The canonical schema creates a single integration point, making ERP diversity a non-issue for rule design. Layer 1 functions as a data X-ray, interrogating data integrity before any rules ever run. This process identifies threats like supplier identity fragmentation, a structural weakness that rules engines cannot see on their own. Here, a single supplier appears across multiple database rows, under different spellings and registration numbers. A standard engine evaluates these independently. Layer 1 normalizes these fragmented records, merging them under a master cluster ID before evaluation. Grouping these identities prevents actors from splitting invoices across duplicate profiles to bypass rolling window spend thresholds. Layer 1 also distinguishes between malicious duplicate payments and technical duplicate rows caused by extraction errors. ReasonGate must never process these technical duplicates, as doing so would misrepresent the business's actual value at risk. Without Layer 1 clustering identity first, the governance system will mathematically understate vendor concentration and financial risk. The X-ray process also resolves semantic conflicts, such as the ambiguity of a generic amount field in raw ERP data. Applying deterministic thresholds to a field that could represent gross, net, or tax amounts produces invalid findings. Layer 1 also scans for orphaned records, identifying payments that exist in the system without matching invoices or purchase orders. It calculates whether the missing link is an actual governance failure or just a broken reference key in the data extract. The system can also deploy free text extraction to recover hidden governance references, like emergency procurement notes buried inside comment sections. It tracks master data instability, flagging when a vendor account is modified just days before a major payment is processed. All of this intelligence culminates in the evidence readiness score, which determines whether the transaction is structurally fit for evaluation. Layer 1 produces diagnostic intelligence that a downstream rules engine cannot safely infer from raw records. This leads to the formal handoff contract, the architectural firewall between the cleansing engineer and the rules engine. Only standardized data crosses this boundary into ReasonGate, including canonical ANDs and the evidence readiness score. ReasonGate evaluates this payload against rigid YAML rules. If it passes, it generates a cryptographic EVID receipt at T0, proving validation. This system deploys through three methods. The first is API gate mode, using Envoy WASM proxies to intercept live JSON requests in cloud environments. The second method is file gate mode, which uses SFTP quarantines to hold and validate payment batches for traditional legacy setups. The third is middleware gate mode, designed to sit directly inside enterprise buses like SAP CPI. ReasonGate provides a deterministic execution boundary, regardless of the underlying infrastructure path. Deploying a hard execution boundary blindly carries a significant operational risk, blocking legitimate supply chain payments and halting business operations. To ensure zero false positives upon deployment, we execute a process called the baseline calibration. We start by taking 90 days of unstructured historical ERP data and processing it entirely through the offline diagnostic pipeline. This diagnostic identifies historical fraud vectors while determining the necessary execution path for production. The system uses this historical data to automatically generate deterministic YAML rules, removing the need for guesswork. Analyzing historical evidence transforms theoretical governance into production-ready execution parameters. Following a live transaction through the completed architecture, it leaves the ERP source, normalizes inside the mapping layer, and passes through the cleansing X-ray. It hits reason gate, earns its eVIDA receipt, and successfully crosses the final execution boundary into the banking network. Governance is achieved over the financial output without modifying the legacy ERP core. Castle OS enforces a binary rule. If there is no valid execution evidence receipt, there is no execution. Enterprise financial governance is no longer reliant on probabilistic oversight. It now operates as a deterministic execution boundary.